So we are still in lesson 4 from chapter 7. I mean 5, sorry. Other classes in chapter 7. And this is part 2. And now we're going to focus in on exterior angles. And today's date is the 15th. So remember we talked about, if you want to go back and look at your notes from Friday, I kind of jumped the gun and told you we figured out how the exterior angles added up to a certain number. And do you guys remember what it said? I heard somebody mumble it. 360. So I'll just do a quick recap. So if I want to figure out exterior angles, what I'm going to do is just extend each of the 3 sides. Okay? And I'm going to choose the simplest triangle I possibly can. I'm going to say that this is an equilateral triangle. Since it's equilateral, that means it's also equiangular. And if it's equiangular and all the angles add up to equal 180, that means each of the angles inside the triangle has to equal 60. And then we talked about when we create the exterior angles, what relationship does the exterior angle have to the angle it's adjacent to? So I'll put a little dot. What relationship does that angle have to the 60 degrees next to it? Savannah? They are supplementary. Very good. And supplementary angles add up to equal? 180. There's Susie. So if the blue angle is 60, what would the purple angle be? Yeah, if they add up to equal 180, then that guy would be 120. And because all of these angles are the same, because all of the interior angles are the same, we have this. So what I'm going to do is draw a fairly crude drawing, and crude in this way means not very professional looking, not rude. Here's this angle, that's 120. Here's this angle, that's 120. And here's this angle, that's 120. If I did like what we did with the interior angles, we could form a straight line. But if I do it with the exterior angles, it forms a circle. And we know that there's always 360 degrees for every circle. So we get the sum of the exterior angles of any polygon is always 360 degrees. Okay? So the exterior angles of any polygon always gives me a sum of 360 degrees. Okay, so you're not going to get asked a worksheet of questions, what's the sum of the exterior angles of this shape? What's the sum of the exterior angles? Because you just write 360, 360, 360, and you'd be done. Okay? So we're going to ask a little bit harder question. The harder question would be, well, what's the measure of an exterior angle for this particular triangle? Okay? So that's what, or this particular polygon. So that's what we're going to work on. Everybody good here? Alrighty, so here we go. What I'm going to ask is, what's the measure, or find the measure, of each exterior angle of each regular polygon. Now, they throw in that word regular to let you know that all the inside angles have to be the same, which then, by definition, all the exterior angles would have to be the same. If they just said polygon, then we wouldn't know what each one would equal, because they could be different amounts depending upon what the interior angles are. So let's do it for a regular hexagon. So the only piece of information I need to take from that, outside of knowing regular means all the angles would be the same, is how many sides does a hexagon have? So how many sides with a hexagon? Not 8. Yeah, it's 6. So it has 6 sides, which means it also has 6 angles. So what do all the exterior angles together have to equal? How much? That's your 360. And all we're going to do is divide it by how many angles I would have. So the answer is 60 degrees. That's it. I know, it is pretty easy, right? All right, let's try another one. Let's do a regular 15-gon. Now, these all have names, but they decided that after about decagon, they stopped naming them. In our book, they started using numbers. And on the worksheet, you did see dodecagon. Did you see that? Yeah. Okay, that's coming up, dodecagon. So decagon is 10, do is like dos, so it's 12-sided figure. So this one has 15 sides. We take the sum of all the exterior angles, which is 360, and we divide by the number of sides, therefore the number of angles, 15. Okay, so 15 goes into 36 twice, which is 30 with 6 left over, and 15 goes into 60 4 times. So each exterior angle would be 24 degrees. Okay. That's about all. You guys want to do one challenge one and see if you guys can do it on your own? Okay, let's do an octagon. All right, let's try. So an octagon has how many sides? 8 sides. The exterior angles all equal what? 360. I'm going to divide it by the number of sides, which is the same as the number of angles. 8 goes into 36 4 times, which is 32 with 4 left over. And 8 goes into 45 times. Very good. 45 is the correct answer. That's pretty much all I got for you today. We got another question. Yes, Savannah. Regular, for all of our purposes, what you're doing today, the assumption is we have regular polygons, because I would not be able to calculate anything unless they were regular, okay? Because they wouldn't all be the same if it wasn't a regular, so it'd be impossible. So I would say in these cases, yeah, that's the only way I can ask you that question, okay? Now, what would be an interesting question is if you know what the exterior angle is, could you figure out what an interior angle is without having to figure out the total number of degrees inside the shape and figure out what each angle, divide that answer by how many sides there were? Would there be an easier way of figuring this out? So let me just draw a picture of this last one. Simon says yes. Okay, so if this angle here is your 45, could you figure out without needing to do the other method what that angle is? Simon, you said yes. How?
You subtract it by 180.
Yeah, not by 180, but from 180. Yeah, because notice, exterior and interior angle together form a straight angle. So this guy, will mark him X. If we take the exterior angle and we add the interior angle, they should equal 180 because that pairing is going to give you a straight angle, which makes them supplementary. And so you could just subtract the 45 from both sides, rename, and you could get that the X value is going to be 135. So you could figure out the interior once you know the exterior. And if you know an interior, you can also figure out the exterior. But it's a lot faster to figure out the exterior this way with taking the total number outside, which is 360. It's always the same number, so that's simple. And then dividing it by the number of sides / number of angles. And then going inside. That's actually a faster way of figuring out an interior angle. My geometry kids often chose this second method instead of the method that you were practicing yesterday, okay? Because it's really easy to calculate an answer, and then it's a simple subtraction after that. Okay? All right, so that's it.